and so to begin programming in earnest. Chapter 2 will see us create our basic C program. It will be called the Hello World program, a very simple program to print the words Hello World on the screen. Every C programmer creates a Hello World program as their very first project. It's almost a tradition. We will also examine the concept of variables and examine the three standard C library functions, printf, scanf, and getchar, and so to begin with the Hello World program. Here is the Dev C++ screen. You'll be seeing a lot of this screen as the course goes on. It's where we'll be doing all of our writing of code and compiling of code. I will now write for you the Hello World program. It starts with the word main, then an open and close round brackets, then an open curly brackets, then we write the line printf hello world. We put a \n on there, and I'll tell you why in a second. Close the brackets, semicolon, and that is the entire program. It's really just one line of code, which is this, printf hello world. The rest of it, well, we'll talk about that in a moment. Before we examine each of the elements of the Hello World program, let's compile it and run it and see if it does what we think it's going to do. This button over here, the Compile Project button, is where we go to compile every program that we're ever going to make. We'll do it now. It's suggesting that we have not yet saved this file, and it's absolutely right. So let's give this file a name. Hello.c. That's a good enough name for a program that prints the words Hello World. We'll store it in our Chapter 1 directory and save. Now the compilation starts. Compilation completed, total errors 0. Notice down the bottom of the screen, hello.c compiled successfully. If it didn't compile successfully, we would see some errors down there. And so we're done. I click on this button and we're back to the main screen again. It compiled successfully. This button here shows us the program running. Let's run it and see if it does what we think it's going to do. Did you see that? That was very quick. It may not even have come up on your screen. I'll click it again. What's happening? Why is it doing that? Well, it's a very simple program. It's printing the words Hello World on the screen, and then the screen that it's printing them on is disappearing because there's nothing else for it to do. So how do we know that it's actually worked and that the words Hello World have come up on the screen? It was far too fast for me to see. Well, here's one way. This is a DOS prompt. We're going to use this DOS prompt to find our C program that's just been compiled and to run it. So I change the directory to the chapter that we were in, Chapter 1 in this case, and I see what's in this directory. I find that we have hello.c, which is the program that we just wrote, and hello.exe, which is the result of the compilation process. The dev C++ program created the hello.exe for us. I'm now going to run the hello.exe file. I do that by simply typing in hello. I could type in hello.exe, but that's unnecessary. I just need to type the word hello. What happens? I get the words Hello World on the screen. So our program is in fact working. That's the most important thing. But I have one or two things to say about this in order for you to understand it properly. Firstly, it looks like this is a DOS program. Well, it sort of is. It's not exactly a DOS program. It's more a program that doesn't create any windows and writes directly to the console. It's difficult to explain, and it's not particularly important. But if you wanted to get exactly the same thing happening in a Windows program, in other words, you wanted to create a window on the screen and then put the words Hello World inside it, it would probably take you about 50 lines of code. And you had to call several library routines that were not part of the standard C library. That's why I didn't want to do it that way. So it might look like you're developing DOS programs here. The actual fact of the matter is you're developing programs that are neither DOS nor Windows nor Unix nor anything else. They're simply generic programs. Still, we're left with a problem. Do we really want to fire up a DOS prompt every time we want to test our program? Well, we could if we wanted to. But there is an alternative. You will recall that the program started and flashed up just for a millisecond and then disappeared again. Is there a way to make it stay on the screen so that we can see what the results of the program were? Yes, there is a way to do that. Let's do that now. Back in our editor, we simply add a line of text to our program. We add another statement to our program as follows. Getchar with a semicolon. Now, let's try and compile that again. Compiling, compiled successfully. OK. And running. Now that looks better. Hello World is on the screen. How do I get rid of it now? I could close it, but that's not the way that I prefer to get rid of it. That little getchar means something. It means it is waiting to get one character from the keyboard. So I'll now enter a character. I'll press enter. The enter key will be my character. I press it, the program finishes, and thus the window disappears. So our program is working properly. It's a two-line program now. The first prints a line on the screen, and the second reads a character from the keyboard. Let's go into our program in a little bit more detail, showing you the specific syntaxes required for programs of this nature. Firstly, the word main. Every C program has a main in it. That's quite important. You cannot write a C program that doesn't have a main. If you do, it won't run. Main is simply a function. It's a very special function in that it is called main, and thus is the first function to be called, but it is a function just like every other function that we're going to discover in C. If you don't know what a function is just yet, don't worry, it will be explained properly. Main is a function, and all functions have open and closed brackets after the name of the function. Also, all functions have curly brackets below the function name, and those curly brackets, the opening and closed curly brackets, enclose every line of code in that function. So we put curly brackets around the two lines of code that we wish to write and compile. And those two lines are as follows, the printf and the getchar. Now printf and getchar, you notice that they've got open and closed brackets as well. Each one of them does. But there's a slight difference. There's a semicolon on the end. A semicolon on the end is very important. It tells the compiler that we are executing a statement. We're not trying to define another function. In fact, we're not just executing any old statement. In this case, we're calling the printf function, and in this case, we're calling the getchar function. With a couple of exceptions, which I'll explain to you when we get there, you must put a semicolon on the end of every C statement. Some other things to notice are as follows. The hello world is inside quotes. Double quotes here and double quotes here. The double quotes indicate this is a literal string. We call it a string literal, in fact. String literal means those are the words that will literally be printed on the console. The \n is the slight exception. The \n means put a new line after the word world, which means move the cursor down onto the next line. That's quite important. Well, you don't need it. If you didn't have the \n there and you ran the program, the cursor would simply be flashing at the end of the word world, waiting for you to press a character. The reason that it's in red at the moment, that all of this text is in red, that is a function of the dev C++ development environment. It shows all string literals in red. We will learn more about the printf function and the getchar function in later modules. Getchar is quite a simple function, but printf is actually quite complex. It does a lot more than what you see on the screen at the moment. Before you begin the next module, see if you can create your own Hello World program and get it to run.